Hello, I'm Amanda Tong from 4E.
And I'm Vincia from 4F.
Today we're going to talk about Chapter 13.2, Rusting. Rusting is a corrosion of iron. Only the corrosion of iron can be called rusting, but not other corrosion of metals. To let rusting occur, we need three things: iron, water, and air. Well, it is reasonable that we need iron for the rusting process, as rusting is a corrosion of iron. But why do we need water and air? Let's discuss the chemical process of rusting first.
Rusting is a slow and complex chemical process. In the initial stage, some iron atoms on the surface lose electrons to form iron-2 ions, while the oxygen molecules from air dissolves in water, and the water molecules accept the electrons lost by iron atoms to form hydroxide ions. Be aware that both reactions occur at the same time, so we can combine these two chemical equations together.
Then the iron-2 ions and hydroxide ions combine to become iron-2 hydroxide precipitate. Note that it is insoluble in water. The iron-2 hydroxide precipitate further reacts with dissolved oxygen and water to form iron-free hydroxide. Note that iron-free hydroxide is also insoluble in water. To further explain, it is because the iron-2 ion in the original precipitate is undergoing oxidation, which means the iron-2 ion loses an electron to become iron-free ion. In this case, oxygen is the oxidizing agent, which accepts the electron lost by iron-2 ion. We will learn more about it in the future.
The iron-free hydroxide will further change into hydrated iron-free oxide. You may be confused why hydroxide is changed to oxide, but no worries. We can use a chemical equation to explain. Note that anhydrous iron-free oxide is not rust, but hydrated iron-free oxide. This is the overall reaction of rusting, where N is a variable number not less than 0. Rust is a reddish-brown solid. Some students may mix up the color with aqueous iron-free iron, which is yellow or brown, as rust is not in aqueous state, and the iron-free iron is combined with other things. It is not yellow nor brown, but reddish-brown. Note that rust formed is just loosely attached to the iron surface, so the iron will rust again when the rust falls off and fresh iron is exposed to air.
Back to the previous point, why do we need water and air? In addition to the supply of hydrogen atoms and oxygen atoms, water acts as an electrolyte, allowing the movement of ions and electrons, while the oxygen in air is the oxidizing agent for the oxidizing process.
We can discuss the examples from our book. For tube A, anhydrous calcium chloride is present, which is a drying agent and absorbs water from air. Thus, tube A has no water for rusting. Note that the word anhydrous is needed. No anhydrous, no mark in exam. For tube B, boiled distilled water has no dissolved air, and the oil layer can prevent air from dissolving into water. Thus, tube B has no air for rusting. You may wonder why boiled distilled water has no dissolved air. Well, it is because when the dissolved air is heated, they gain energy. This energy can get rid of the attraction of polar water molecules and escape from water.
For tube C, water is present, and air in the test tube can dissolve into water, so tube C has water and air to be in contact with iron and thus rusting occurs. This is the end of our sharing. Thank you.